This is Free Range Digital Design Foundation Modeling, Chapter 12, Lecture 1. So what we've been working with so far is binary numbers, but they've all been positive binary numbers. What we need to get to is working with negative numbers, so we need representations that are sign representations. So this chapter is primarily about the sign representations of binary numbers. So we'll be converting between these representations. We'll be looking at a couple different representations, but our emphasis is going to be on radix complement versions, which is commonly known as 2's complement. This is what everyone uses. The other versions are kind of learning tools at the very best. So when we have a negative number in decimal, we toss a negative sign in front of it, and everyone knows it is negative. So we don't have that option in binary, particularly in hardware. I mean, we could use a piece of paper, but in hardware, there's no such thing as a dash or a minus sign. So we represent it with a bit. So if we represent it with a bit, we need to do two things. We need to say which bit it is, and we need to define what that bit means. The bit's a 1. By convention, it's a negative number. If that bit's a 0, it's by convention going to be a positive number. And that bit we're talking about, location-wise, is the leftmost bit in the binary number we're considering. It's always the leftmost bit. That bit being set indicates it's a negative number. That's a convention we always use, and we'll stick with that in this course. We're going to discuss three representations, which is sign magnitude, diminished radix complement, and radix complement. I'll spend most of the time with radix complement, which is 2's complement. First representation is sign magnitude. Leftmost bit's a sign bit. All the other bits are referred to as the magnitude bits. What we're interested in doing with this number is changing the sign of it, which means multiplying it by -1. The way we do that, we essentially invert the sign bit, or toggle the sign bit. Or sign bit's a 1, we change it to 0. If it's a 0, we change it to a 1. When we're doing that conversion, what we need to do is kind of remember what the sign is. If it's negative, we need to toss on a negative sign to the result of our conversion of the magnitude bits. Now the magnitude bits convert just like a normal binary to a decimal conversion using unsigned binary. Examples here, what we want to do is change the sign of these numbers. They're in SM format, sign magnitude, and what we know is all we need to do is toggle the sign bit. Here's the sign bit. I'm going to toggle that and keep all the other bits the same. There's my answer. So this one started off as a negative number, ended up positive, which is what changing the sign's all about. This one is a positive number. I change the sign. I bring the other bits down, and it's my positive version. This is my negative version of that number. Next thing we want to do is take these numbers and convert them from binary to decimal. And first number is positive, so I don't really need to do anything special with it. It just becomes a normal binary to decimal conversion, and there's many ways to do this. Probably the best way is plug it into a calculator, but in my mind I kind of convert it to hexadecimal in my head and then do the math. So this is a 6 and this is a 7. That results in 6 times 16 plus the 7. So this is 16 to the 1. And so this is going to be 6 times 16 is 96 plus 7 is 103. And it looks good. I could add a positive sign there if I wanted to, but conventionally we don't really put that there. This number is, I'm looking at this thing, it's a negative number. I'm going to remember that, and then I have to convert the other bits. I'm still going to do a group of 4s here. This is essentially a 0, so this ends up being, the code for this is actually a D. D is hexadecimal, and that's 13. So this number is 13. I can't forget that it was negative to start off with, and there's my solution. The second format is diminished radix complement, and it's similar to sign magnitude. Leftmost bit's a sign bit, all the other bits are magnitude bits, but what's different is to change the sign of that number, we invert all the bits. Not just the sign bit, we invert all the bits. And to convert that to decimal, if it's a positive number, it's just a normal binary to decimal conversion like we've been doing with unsigned binary. If it's a negative number, we got to toggle all the bits, and then convert it. And remember that it's negative and add the negative sign. So let's do a couple examples on that. The first issue is, let's take these numbers here. They're in DRC format, and what we're going to do is change the sign of these things, which in DRC format means toggling all the bits. So not just the sign bit. There it is. I toggled all the bits. So this was started off as a positive number, it ended up as a negative number. So in this format, this number here, it's obviously a negative number because the sign bit is set. So I'm going to toggle all those, and this is a negative, and this comes out positive, and that's it. Now next example here is I'm going to convert these numbers in DRC format into decimal. And so I'm going to look at this. I'm still do the same group of 4s, hex to decimal conversion. So I'm going to do a group of 4s on this. I see that it's positive, so I'm just going to ignore that. So this is a 6, and this is a 7. You've seen this before. This is 6 times 16 plus 7 equals 103. So this number here is negative, so the only way I know how to convert this is convert it to positive, and remember that it started off as negative, so it's 0, 1, 0, 0, 1, 0, toggling all the bits, and I'm going to do a group of 4s on that. This is a 1, 2, so this equals 1 times 16 plus 2 equals 18. Almost done. It was a negative number, and there's my answer. Radix complement is a little bit different. Leftmost bit is always the sign bit. It's still the sign bit, but the other bits are questionable whether they're magnitude bits or not. I've been toiling with this. I don't really know. It's kind of a semantic argument. That's why I put a question mark here. The issue is to change the sign of this thing. There's two ways to do it. One is hardware based. This is kind of the hardware based thing I need to do, which will make sense later. I invert all the bits and add 1. Okay, that's the same thing as the 2's complement trick, which is for humans, and we'll go over that next. To convert these numbers to decimal, if it's a positive number, I just do a normal binary to decimal conversion. If it's a negative number, I need to take a 2's complement, and then I do a normal binary to decimal conversion. And I remember the fact that it's negative, and I toss in the negative sign. So these are, the example says take the 2's complement of these numbers. That's the same thing as changing the sign of the numbers, same thing as multiplying the number by -1. So changing the sign means, for RC format numbers, means taking a 2's complement, which means, you're multiplying by -1. Okay, so it's a special trick here. Now I could add, once again, I could toggle all these bits here and add 1. I don't think I want to do that because I'll probably make a mistake. What I'm going to do is show you the 2's complement trick. So the 2's complement trick is, you start at the right side and you scan towards the left until you see the first one, and there's my first one, and I bring it down. All the other values I'm going to toggle. Okay, so this is my number here. It started off positive, it ended up negative. So once again, I start from the right side, I read right to left until I find the first one. Once I find the first one, I bring it down, and then I toggle all the other bits as I traverse towards the left side. So here's another number. It's a negative number. It starts off as a negative number, but here it is. There's the first bit. 1 0 0 1 0, and it ends up as a positive number. Lastly, so it's pretty straightforward. This one's a little bit different. So once again, I'm starting at this side. I'm bringing these numbers down. I still haven't seen a 1. I finally see a 1. I bring it down, and I toggle all the other bits. Okay, so once again, this starts off as, get this right here. It starts off as a negative number, ends up as a positive number. Okay, so what I need to do is convert these numbers in RC format to the decimal equivalent. So let's do this. And this number, I look at this, I see that it's a positive number, so I don't have to do anything special to it. I can convert it directly. So this is going to be 6 times 16 plus 7, which is 103. You've seen that a couple times before. But this one's a more interesting one here. I can see that it's negative. Sign bit set. So what I need to do is take a 2's complement and then do the conversion. So this is going to be, bring down the 1. Remember, I'm scanning left or right on this thing, and toggle all the other bits. So what I end up with is this number here. I'm going to do the group of 4s on it to help me convert it, to kind of convert it in my head from hex to binary. So this is going to be a 1, this is going to be a 3. So this is going to be 1 times 16 to the first plus 3 equals 19. It started off as a negative number there, so I need to put that negative sign in there, and then I'm done with that.